Tonight we drift far beyond the familiar constellations, far beyond the bright neighborhoods of ordinary stars, into a region of darkness so vast that it seems almost impossible to measure. There is no sunrise here, no sunset, no warm glow spilling across a horizon. Above you, below you, and in every direction stretches an ocean of blackness sprinkled with distant points of light. And beside you floats something that should feel impossible. A planet, a world, a silent sphere of rock and ice wandering alone between the stars. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're settling in, leave a comment sharing your location and local time. It's always fascinating to see where on Earth people are joining these journeys from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift closer to the wandering planet. At first it appears completely invisible. Only after your eyes adjust do you notice a faint outline against the distant glow of the Milky Way. It reflects almost no light because there is almost no light to reflect. This world has no parent star. No familiar sun warms its surface. No golden dawn arrives each morning. Instead, it travels endlessly through the dark spaces separating one stellar system from another. The thought feels strange. Planets, after all, are supposed to orbit stars. That is the image most people carry in their minds. A bright star at the center. Worlds moving gracefully around it. Yet the universe rarely feels obligated to follow our expectations. Astronomers now believe there may be billions, perhaps even trillions, of these wandering planets scattered throughout our galaxy. That is an established scientific fact. Many have likely been thrown from their original homes by gravitational encounters. Others may have formed alone from the beginning. We are still trying to understand their true numbers. And that uncertainty introduces the mystery that will accompany us throughout tonight's journey. If planets can wander freely through interstellar darkness, how many are out there? How many have never seen a sunrise? How many have spent billions of years alone? You float closer. The planet beneath you is frozen. Its surface resembles a landscape carved from black glass and pale ice. Vast plains stretch toward horizons that disappear into darkness. Mountain ranges cast shadows so deep they seem to merge with space itself. There is no atmosphere visible from here. No clouds. No weather. No sign of life. At least, not yet. One of the surprising discoveries of modern astronomy is that a rogue planet does not necessarily need a nearby star to remain active. That sounds almost absurd. A bit like discovering your refrigerator has decided to become a tropical beach resort. Yet physics allows strange possibilities. Deep beneath a frozen crust, radioactive elements inside a planet can generate heat. The slow decay of uranium, thorium, and other materials can warm the interior for billions of years. On Earth, radioactive heating helps drive volcanic activity and plate tectonics. On a rogue planet, similar processes might create hidden underground oceans. Imagine that. A frozen world drifting through eternal night while an ocean quietly moves beneath kilometers of ice. The surface appears dead. The interior may be alive with motion. Perhaps even chemistry. Perhaps even something more. Nobody knows. That uncertainty is part of what makes rogue planets so captivating. The more astronomers learn about the universe, the more they discover environments that challenge old assumptions. Life was once thought impossible around deep-sea hydrothermal vents. Then we found entire ecosystems thriving there. Planets were once assumed to exist only around stars like our Sun. Then we discovered thousands of exoplanets orbiting wildly different stars. Some worlds rain molten glass. Others orbit two suns. Some are larger than Jupiter but less dense than cotton candy. The universe continues to reveal possibilities that would have sounded ridiculous only decades ago. It is almost as if reality enjoys keeping scientists humble. Which, to be fair, is probably healthy. Otherwise, physicists might become even more confident than they already are. And a confident physicist is a force almost as difficult to stop as a black hole. You continue drifting. Ahead, the Milky Way stretches across the darkness like a luminous river. From here, the galaxy feels both enormous and delicate. Hundreds of billions of stars, countless planets, immense clouds of gas and dust, hidden black holes, invisible dark matter, all bound together by gravity. And somewhere among those countless stars, this wandering planet once belonged. That realization changes how you see it. This world had a past. Long ago, perhaps billions of years earlier, it may have circled a young star. Maybe it shared its system with other planets. Perhaps giant worlds migrated inward and outward, reshaping gravitational pathways like cosmic bulldozers. One close encounter might have been enough. A brief gravitational interaction. A tiny change in velocity. And suddenly the planet's future changed forever. Instead of remaining in orbit, it escaped. Cast outward. Not destroyed. Not shattered. Simply released into the darkness. Gravity, the force that creates order throughout the cosmos, can also create exile. That duality appears everywhere in astronomy. The same force that forms galaxies can tear them apart. The same gravity that creates stars eventually causes some stars to collapse into black holes. Creation and separation often arrive together. As you drift over the frozen hemisphere, you begin noticing impact craters. Thousands of them. Some ancient. Some enormous. Each one records a collision from a forgotten era. Unlike Earth, where weather and geology erase scars over time, this lonely world may preserve a history stretching back billions of years. It carries memories written directly into its surface. But there is a problem. Nobody may ever read them. Most rogue planets are astonishingly difficult to detect. They emit little light. They reflect little light. They spend their lives hidden between stars. Sometimes astronomers discover them when they briefly pass in front of distant stars, causing subtle changes in brightness. Other times they reveal themselves through gravitational microlensing, a phenomenon predicted by Einstein's theory of relativity. Gravity can bend light. When a massive object passes between Earth and a distant star, it acts like a lens, briefly magnifying the background light. For a short time, an invisible object becomes visible through its gravitational influence. A remarkable idea. You cannot see the planet directly, but you can see what its gravity does. In some ways, much of astronomy works like that. Dark matter remains invisible. Black holes cannot be observed directly. The earliest moments after the Big Bang remain hidden behind physical limits. Again and again, scientists study effects rather than objects, footprints rather than footsteps, shadows rather than forms. And tonight's wandering planet belongs firmly to that tradition. A world revealed not by its light, but by the subtle distortions it creates. You look outward once more. The stars seem distant beyond imagination. The nearest one may be trillions of kilometers away. Yet even that distance feels small compared to the scale of the galaxy itself. The rogue planet continues moving silently. No destination. No orbit. No apparent purpose. Just motion. Endless motion. And as you accompany it through the darkness, another question begins quietly forming. If billions of worlds wander between the stars, could some of them carry secrets older than entire civilizations? Could some have witnessed chapters of cosmic history that ordinary planets never experienced? And could the darkness between stars be far less empty than it appears? For now, those questions remain unanswered. The planet drifts onward. And so do you. Together, entering the vast wilderness that lies between the lights. The darkness around you remains almost unchanged. The rogue planet continues its silent journey through interstellar space, moving along a path so immense that even millions of years might feel like a brief moment in comparison. Behind you, the distant glow of the Milky Way hangs like a silver cloud stretched across eternity. Ahead, there is only more darkness. And yet, to understand why this lonely world exists at all, you must travel backward. Not through space, but through history. The mystery of rogue planets did not begin with their discovery. It began with an assumption. For most of human history, planets and stars seemed inseparable. Ancient skywatchers observed wandering points of light moving among the constellations. The word planet itself comes from a Greek term meaning wanderer. Ironically, the first planets ever identified were named for their wandering behavior, yet nobody imagined they could wander completely free of stars. The idea would have sounded absurd. A planet without a sun was like a fish without water, possible only in imagination. Even after the scientific revolution transformed astronomy, the picture remained largely unchanged. When astronomers learned that Earth orbited the Sun, and later discovered other planets moving around their own stars, the universe seemed organized according to a simple rule. Stars create planetary systems. Planets remain bound to stars. Order prevails. Then, as often happens in science, reality became more interesting. One of the established facts of modern astronomy is that planetary systems are surprisingly chaotic during their early development. Young stars are surrounded by vast disks of gas and dust. Within these disks, tiny grains collide and stick together. Over millions of years, those grains become rocks, the rocks become planetesimals, and the planetesimals grow into worlds. At least, that is the simplified version. The actual process resembles a cosmic demolition derby. Massive objects tug on one another. Orbits shift. Collisions occur. Gravity constantly reshapes the architecture of developing systems. Sometimes entire planets are pushed inward toward their stars. Sometimes they migrate outward. And sometimes they are ejected completely. Imagine standing in a crowded room where everyone is gently bumping into one another. Most people remain inside. A few drift toward the walls. But every so often, someone gets pushed directly through the doorway. That is roughly what can happen inside a young planetary system. A giant planet, perhaps several times the mass of Jupiter, passes close to a smaller world. Gravity exchanges energy. One object loses some. The other gains some. The smaller planet accelerates. Its orbit stretches farther and farther. Eventually, it reaches escape velocity. And just like that, it is gone. Not destroyed. Not consumed. Simply released into interstellar space. You glance down at the frozen world beneath you. Perhaps that is exactly what happened here. Perhaps billions of years ago this planet enjoyed blue skies. Perhaps sunlight once reflected from oceans. Perhaps moons once circled overhead. Or perhaps none of that happened. Because another surprising possibility exists. Some rogue planets may never have belonged to stars at all. This idea emerged when astronomers began studying the formation of stars themselves. Inside giant molecular clouds, gravity causes enormous regions of gas to collapse. Usually the collapsing material becomes a star. But not always. Sometimes the collapsing mass is too small. Too little material gathers together. The object never ignites nuclear fusion. It never becomes a true star. Instead, it forms something in between, a brown dwarf or perhaps a planetary mass object. A world born alone. A cosmic orphan from the very beginning. That possibility changes the story completely. Not every rogue planet may be an exile. Some may be natural products of the universe's star-forming machinery. They did not lose a home. They never had one. Astronomers are still trying to determine which explanation dominates. The answer remains uncertain. And uncertainty, as you are beginning to notice, appears everywhere in deep space astronomy. The farther you move from familiar environments, the more mysteries accumulate. You continue drifting. The planet's frozen terrain slowly rotates beneath you. Far away, a star briefly flashes as the planet passes in front of it. The event is subtle, almost invisible. Yet such tiny changes have become one of astronomy's most powerful tools. In recent decades, scientists have discovered thousands of exoplanets orbiting distant stars. Many were found through transit observations. When a planet crosses in front of its star, the star becomes slightly dimmer. Sensitive instruments can detect the change. Rogue planets are harder, much harder. Since they orbit no star, there is often nothing obvious to reveal their presence. Yet Einstein provided a solution more than a century ago. According to general relativity, gravity bends spacetime. Light follows those curves. When a rogue planet passes between Earth and a distant star, its gravity briefly magnifies the background light. The phenomenon is called gravitational microlensing. For a short moment, an invisible world announces itself. Then it vanishes again, like a ghost leaving footprints in fresh snow. The observation lasts days or weeks. The planet disappears. The evidence remains. One particularly fascinating discovery occurred when astronomers detected isolated planetary mass objects wandering through our galaxy without obvious host stars. These observations suggested that rogue planets may be astonishingly common. Some estimates indicate there could be more rogue planets than stars in the Milky Way. Think about that for a moment. The night sky contains hundreds of billions of stars. Yet hidden among them may be even more worlds moving through darkness. An entire unseen population. A second galaxy concealed within the first. Not invisible because it is exotic. Invisible because it is cold, dark, and distant. The universe often hides its largest populations in the most inconvenient places. A fact that must occasionally make astronomers wonder whether the cosmos enjoys practical jokes. If so, it possesses exceptional patience. Its jokes take billions of years to develop. As the rogue planet continues forward, you begin noticing how isolated it truly is. The nearest star may lie several light years away. Light itself requires years to bridge the gap. Radio signals would take years. Spacecraft would take tens of thousands. Even the fastest human-made probes would appear nearly motionless on such scales. The distances separating stars are difficult to grasp. Planets orbit within relatively tiny regions compared to the immense voids between stellar systems. The solar system feels vast when viewed from Earth. Yet compared to interstellar space, It resembles a tiny island surrounded by an unimaginably large ocean. And this rogue planet is crossing that ocean alone. The realization carries a certain melancholy, but also wonder, because loneliness in astronomy does not necessarily mean emptiness. The space surrounding you contains thin clouds of hydrogen, invisible magnetic fields, high-energy particles known as cosmic rays, the gravitational influence of dark matter, ripples from distant stellar explosions. Even here, in apparent nothingness, the universe remains active. Something is always happening. Something is always moving. Something is always waiting to be discovered. That brings you back to the central mystery. Astronomers know rogue planets exist. They know gravity can create them. They know some wander through the galaxy without stars. But one question remains stubbornly unanswered. How many are truly out there? Thousands? Billions? Trillions? Current observations reveal only a tiny fraction of what may exist. The overwhelming majority remain hidden, unseen, undetected, drifting quietly beyond our instruments. The frozen world beneath you belongs to that hidden population. A representative of a vast cosmic wilderness humanity has barely begun to explore. And as you continue following its journey through the darkness, another possibility begins to emerge. What if some of these worlds are not merely frozen rocks? What if beneath their silent surfaces, entire hidden environments are waiting? Environments protected from the cold, protected from the vacuum, protected perhaps for billions of years. The darkness between stars may contain more than wandering planets. It may contain places where the story of life itself could unfold in secret. The rogue planet moves onward through the immense wilderness between the stars. You remain beside it, watching as endless darkness unfolds in every direction. There is still no sunrise, no glowing horizon, no familiar celestial rhythm marking the passage of days. Only distant starlight, scattered across space like tiny lanterns floating far beyond a black ocean. The longer you travel, the more unusual the situation begins to feel. Life on Earth evolved beneath a dependable sky. Every creature, every forest, every civilization learned to measure existence through repeating cycles. Day and night, summer and winter, moonrise and sunrise. But here, aboard a wandering planet, those cycles have vanished completely. Time itself feels different. Not because physics has changed, but because your usual landmarks have disappeared. Without a nearby sun, there is no obvious clock, no morning, no evening, just continuous darkness stretching across millions of years. And surprisingly, that darkness may not be as empty as it first appears. One established scientific fact is that interstellar space contains enormous amounts of matter. Not enough to resemble clouds or oceans. Not enough to sustain breathing. But enough to fill the galaxy with a thin, nearly invisible medium. Hydrogen atoms drift through the darkness. Dust grains float between the stars. Magnetic fields weave quietly across immense distances. High-energy particles race through space at nearly the speed of light. Even the emptiest regions are never truly empty. As you glide above the frozen planet, you begin imagining the route it may have traveled. Perhaps it once orbited a star near the crowded center of the Milky Way. Perhaps it was ejected during an ancient gravitational encounter. Since then, it may have crossed spiral arms, past molecular clouds, and drifted through stellar neighborhoods that no longer exist. Stars are not permanent. Entire regions of the galaxy slowly change over billions of years. Constellations dissolve. New stars emerge. Old stars die. Galaxies evolve. Meanwhile, the rogue planet simply continues moving. A traveler with no destination. A cosmic ship without a harbor. One surprising realization about the Milky Way is that much of it remains unexplored, even in theory. Humanity possesses detailed maps of many nearby stars, yet vast regions remain poorly understood. The galaxy is roughly 100,000 light-years across. Even light requires 100,000 years to travel from one side to the other. Our species has been using radio technology for barely more than a century. On galactic scales, that is less than a blink. You and the rogue planet are wandering through a realm so large that humanity has only begun to comprehend its true dimensions. And somewhere ahead lies another mystery. A mystery hidden within the darkness itself. As the planet drifts onward, you notice that stars seem slightly denser in one direction. The difference is subtle, almost imperceptible, yet it hints at one of the great truths of astronomy. The universe is not evenly arranged. Gravity gathers matter into structures. Stars collect into clusters. Clusters gather into galaxies. Galaxies assemble into larger networks. Everywhere, gravity shapes the cosmos into patterns. But here is the strange part. Visible matter cannot fully explain those patterns. Galaxies rotate too quickly. Galaxy clusters contain too much gravitational pull. Large-scale structures appear more organized than expected. Something unseen appears to be influencing everything. Astronomers call it dark matter. And despite decades of study, nobody knows exactly what it is. You cannot see dark matter. It emits no light, reflects no light, absorbs almost no light. Yet its gravitational influence seems to outweigh all visible matter combined. The rogue planet drifts through a galaxy largely shaped by something invisible. That idea feels almost poetic. A world hidden in darkness moving through a universe governed by hidden matter. Mystery layered upon mystery. Of course, scientists have developed numerous explanations. Dark matter could consist of unknown particles. Perhaps entirely new forms of matter exist beyond the standard model of particle physics. Maybe hidden populations of exotic objects contribute to the missing mass. Some theories even suggest that our understanding of gravity itself may be incomplete. At present, observations strongly support the existence of dark matter, but its true identity remains unresolved. You continue forward. Hours pass, or perhaps centuries. Out here, the distinction feels less important. The rogue planet rotates slowly beneath you. Its frozen plains glimmer faintly in reflected starlight. Then your attention shifts toward the sky. Among the countless stars appears a region of unusual darkness. A vast gap. An absence. A place where surprisingly few galaxies seem to exist. This introduces another fascinating feature of the cosmos. Cosmic voids. These enormous regions contain far fewer galaxies than expected. Some stretch across hundreds of millions of light-years. Compared to the crowded cosmic web surrounding them, they resemble gigantic empty bubbles. The surprising observation is that the universe appears organized like a vast network. Galaxies gather along filaments. Those filaments surround enormous voids. The overall structure resembles a three-dimensional spiderweb extending across unimaginable distances. The rogue planet is tiny compared to such structures. Earth is tiny. Stars are tiny. Even galaxies become small when viewed against the architecture of the observable universe. And yet, despite decades of observations, Scientists still debate aspects of how these structures formed. Dark matter likely played a crucial role. So did cosmic inflation during the universe's earliest moments. But many details remain uncertain. The deeper astronomers look, the more questions appear. A recurring theme tonight. One mystery leading naturally into another. You drift lower over the planet. The surface remains frozen and silent. Yet your imagination begins exploring what may lie beneath. The planet has traveled through darkness for billions of years. Its exterior temperature may be unimaginably cold. Far colder than Antarctica. Far colder than any natural environment on Earth. And yet temperature inside a planet often behaves differently. Pressure increases with depth. Heat becomes trapped. Radioactive elements continue releasing energy. Some theoretical studies suggest that thick layers of ice could act as insulation. Beneath them, liquid water might persist. That possibility is extraordinary. Life as we know it requires liquid water. And here, in the most isolated regions of the galaxy, liquid water may still exist. No sunlight required. No nearby star required. Only internal heat and enough time. The universe occasionally demonstrates remarkable creativity. A frozen world drifting through endless darkness somehow preserving warmth beneath its surface. It sounds almost contradictory. Yet physics allows it. Whether life actually exists in such environments remains unknown. That is the unresolved mystery. Scientists have not discovered life beyond Earth. Not yet. But rogue planets expand the number of possible habitats dramatically. Instead of searching only around stars, perhaps future civilizations will search among wandering worlds as well. The thought transforms the darkness around you. The empty void no longer feels entirely empty. Every unseen rogue planet becomes a possibility. A hidden ocean. A buried ecosystem. A chapter of cosmic history nobody has read. Ahead, the Milky Way continues stretching across the sky. The rogue planet moves steadily onward. And as you accompany it deeper into the galactic wilderness, you begin realizing something profound. The darkness between stars is not merely a gap separating destinations. It is a destination itself. A vast frontier filled with invisible structures, hidden worlds, and unanswered questions. And somewhere within that frontier, beneath kilometers of ancient ice, another mystery may already be waiting. The rogue planet continues through the darkness. Far behind you, entire stellar neighborhoods have already faded into the distance. Ahead, there are only more centuries, more millennia, more millions of years of silent travel. Yet tonight, your attention turns away from the stars. Instead, you look downward, beneath the frozen crust, beneath the ancient impact scars, beneath the endless night. Because one of the most intriguing possibilities in modern astronomy is that a world can appear completely dead on the outside while remaining surprisingly active within. At first glance, that sounds unlikely. If a planet loses its star, surely it should freeze solid forever. Case closed. Mystery solved. Everyone goes home. Astronomers, unfortunately for their sleep schedules, discovered that the universe is rarely that cooperative. The surface of a rogue planet may indeed become extraordinarily cold. Temperatures could plunge hundreds of degrees below freezing. Atmospheres may collapse. Oceans may solidify. Sunlight disappears entirely. Yet deep underground, a different story may unfold. An established scientific fact is that planets generate internal heat. Earth itself contains a hot interior powered partly by leftover energy from its formation and partly by radioactive decay. Even today, Deep within our planet, temperatures remain high enough to melt rock. Volcanoes, earthquakes, and tectonic activity are reminders that Earth's interior remains alive with energy. Now imagine a larger world, perhaps several times Earth's mass, perhaps wrapped beneath a thick shell of ice. That icy shell acts like a giant blanket. Heat escapes very slowly. Over immense spans of time, warmth may accumulate beneath the surface. The result could be extraordinary. An underground ocean, not a small lake, not a hidden reservoir. An entire ocean stretching beneath a frozen crust that may be tens or even hundreds of kilometers thick. You picture it now. Above, darkness. Below, water. An ocean hidden from every star. An ocean that has never seen sunlight. An ocean that may have existed for billions of years. The image feels strangely peaceful. And surprisingly, it is not entirely speculative. Within our own solar system, moons such as Europa and Enceladus provide powerful examples. Both possess icy exteriors. Both appear capable of harboring liquid water beneath their surfaces. Neither depends solely on sunlight for internal warmth. The lesson is important. Liquid water does not automatically require a nearby star. The universe has more than one way of keeping an ocean alive. As you imagine descending through the frozen crust of the rogue planet, the darkness changes. The ice above becomes thicker. Pressure increases. The cold begins to fade. Eventually, beneath kilometers of frozen rock and ice, you reach a vast hidden sea. No sunlight penetrates here. No stars shine overhead. Yet the water moves slowly through immense underground chambers. Warm currents rise from deeper layers. Minerals dissolve into the ocean. Chemical reactions continue year after year. Million after million of years. One surprising observation from Earth helps make this scenario even more fascinating. Life here thrives in places once thought impossible. Deep-sea hydrothermal vents support entire ecosystems without sunlight. Microorganisms draw energy from chemistry rather than photosynthesis. Tubeworms, bacteria, and other organisms flourish around volcanic activity deep beneath the ocean floor. The discovery transformed biology. Sunlight was no longer the only foundation for life. Chemistry could also sustain ecosystems. And if that is true on Earth, could similar processes occur elsewhere? That question remains unanswered. It is one of the great unresolved mysteries of astrobiology. Scientists do not know whether rogue planets can support life. No evidence currently confirms it. Yet the possibility remains scientifically plausible. A hidden ocean. A stable environment. Chemical energy. Billions of years available for evolution. The ingredients may exist. Whether the recipe succeeds remains unknown. The rogue planet drifts onward. Meanwhile, your imagination explores even stranger possibilities. What if entire biospheres exist beneath frozen crusts? What if some wandering worlds host microbial ecosystems older than multicellular life on Earth? What if civilizations, however unlikely, could someday emerge beneath endless darkness, never knowing stars existed? It is a breathtaking thought experiment. Imagine intelligent beings developing within a sealed underground ocean. Their universe would consist of water, rock, and darkness. Astronomy might seem impossible. The existence of galaxies might appear unimaginable. Black holes, nebulae, and distant stars would remain hidden forever. Their entire understanding of reality would emerge from a tiny pocket of warmth drifting through interstellar space. A rather humbling reminder that every civilization, including our own, views the universe through limited windows. Of course, there is no evidence such civilizations exist. This remains speculation. Yet astronomy often advances by asking questions before answers become available. Sometimes the questions themselves reveal new possibilities. You continue descending deeper. Far beneath the ocean, heat rises from the planetary interior. Molten rock moves slowly through hidden layers. Radioactive elements release energy atom by atom. The process is incredibly gradual. But the universe is patient. Given enough time, tiny effects become enormous. That principle appears everywhere in cosmology. Stars form because gravity acts continuously for millions of years. Galaxies emerge because matter accumulates over billions. Even black holes can grow from modest beginnings into monsters containing billions of solar masses. Time transforms small influences into cosmic architecture. The rogue planet is another example. Its hidden warmth survives not because it is powerful, but because it persists. And persistence is one of nature's greatest forces. Above the ocean, the frozen crust remains untouched by sunlight. Above the crust lies endless darkness. And beyond that darkness stretch the stars of the Milky Way. The planet continues wandering. Silent, ancient, almost invisible. Yet perhaps not empty. Perhaps beneath the frozen shell, something stirs. A current. A chemical reaction. A primitive organism, or perhaps nothing at all. That uncertainty is what makes the mystery endure. Because the deeper you travel into the darkness between stars, the more you realize that the universe may be hiding entire worlds of possibility beneath surfaces we rarely think to examine. And somewhere beyond this frozen ocean, another invisible influence waits. A force shaping galaxies, bending gravity, and quietly guiding the journey of countless wandering worlds. The mystery of dark matter is beginning to emerge. The hidden ocean fades behind you. The imagined currents beneath the frozen crust continue their silent motion as the rogue planet carries you onward through the darkness between the stars. Above, the Milky Way stretches across the sky like a river of distant fire. Below, the wandering world remains cold and nearly invisible. And around both of you lies something even stranger. Something that may outweigh every star, every planet, every nebula, and every black hole you can see. Yet it cannot be seen at all. Dark matter. The name sounds mysterious, almost poetic, but it was not chosen to sound dramatic. Astronomers gave it that name because they genuinely do not know what it is. And sometimes scientific terminology is refreshingly honest. Imagine spending decades studying a cosmic phenomenon and eventually concluding, well, it is dark, and it appears to be matter. Not exactly the kind of title that wins marketing awards. Yet behind the simple name lies one of the greatest mysteries in modern science. As you drift beside the rogue planet, you begin noticing something unusual about the galaxy around you. The stars appear organized, not randomly scattered, not chaotically distributed. Instead, they belong to larger structures, clusters, streams, galactic arms. Immense patterns stretching across thousands and millions of light years. Gravity creates those patterns. That much is clear. The mystery appears when astronomers calculate how much gravity should exist. One established scientific fact is that galaxies rotate too quickly. According to the visible matter alone, many galaxies should not remain stable. Stars near their outer edges move so rapidly that they ought to escape into intergalactic space. Yet they do not. Something provides additional gravitational pull. something unseen. The first clues emerged during the 20th century when astronomers carefully measured the motions of galaxies and galaxy clusters. Again and again, calculations produced the same result. The visible universe seemed far too light. It was as if someone weighed a ship, counted only the passengers on deck, and somehow discovered the vessel was carrying 10 times more mass than anyone could find. The missing weight had to be somewhere. And so the mystery began. The rogue planet beneath you continues its journey through a galaxy that appears to be embedded within an enormous halo of invisible matter. Without that hidden matter, the Milky Way might look entirely different. Perhaps it would never have formed in its current shape. Perhaps stars like the Sun would never have emerged. Perhaps Earth itself would never exist. Dark matter may have quietly influenced your existence long before life appeared on our planet. That realization gives the mystery a strangely personal quality. You are not studying some distant curiosity. You may be studying one of the fundamental ingredients that helped create everything familiar. Yet despite its importance, dark matter remains elusive. You cannot photograph it directly. You cannot collect samples. You cannot observe it glowing among the stars. Instead, astronomers detect its influence. Its gravity bends light. Its gravity shapes galaxies. Its gravity guides cosmic evolution. Like footprints crossing fresh snow, the evidence is everywhere. The traveler remains hidden. As you look toward the distant galactic center, another surprising observation emerges. Scientists estimate that ordinary matter, the matter making up planets, stars, people, oceans, and galaxies, accounts for only a small fraction of the universe. Everything you have ever touched belongs to that tiny fraction. The vast majority appears to consist of dark matter and another even stranger component called dark energy. Think about that for a moment. Human civilization has spent centuries studying reality. Yet most of the cosmos appears to be made of things we do not fully understand. There is something wonderfully humbling about that. The universe occasionally reminds us that knowledge is not a destination. It is a journey, and often a very confusing journey. A bit like assembling a puzzle while discovering that most of the pieces are invisible. The rogue planet drifts onward. Far ahead, stars cluster into distant regions of brightness. Their motions, too, are influenced by invisible structures. Modern computer simulations suggest that dark matter forms enormous frameworks throughout the universe. Galaxies appear to grow inside these frameworks much like dew forming along strands of a spiderweb. The visible cosmos may simply illuminate a much larger invisible architecture. You begin imagining those hidden structures. Gigantic rivers of dark matter crossing the galaxy. Massive concentrations surrounding galaxy clusters. Invisible mountains of gravity stretching through deep space. The rogue planet passes through them constantly. Earth passes through them constantly. You are likely moving through dark matter right now. Yet nothing in your daily experience reveals its presence. That is one reason the mystery remains so difficult. Dark matter interacts very weakly with ordinary matter. If it interacted strongly, scientists would have identified it long ago. Instead, it slips through detection efforts again and again. Some theories propose entirely new particles. Others suggest exotic forms of matter left over from the early universe. Researchers continue searching in underground laboratories, particle accelerators, and astronomical surveys. So far, the definitive answer remains elusive. The universe is keeping this particular secret remarkably well. And as often happens in astronomy, solving one mystery reveals another. Because dark matter is not the only invisible influence shaping the cosmos. Something even stranger awaits. Something that appears to affect the expansion of the universe itself. Before reaching that mystery, however, your attention returns briefly to the rogue planet. This lonely world has spent billions of years wandering through gravitational landscapes it cannot see. Dark matter halos. Galactic tides. Invisible currents of mass. The planet responds to those influences regardless of whether anyone observes them. In a way, the universe behaves similarly. Many of its most important components remain hidden from direct observation. Yet their effects shape everything around them. The same principle appears elsewhere in science. Black holes reveal themselves through gravity. Ancient particles reveal themselves through traces in detectors. The earliest moments after the Big Bang reveal themselves through faint patterns in cosmic radiation. Astronomers often learn about reality indirectly. They become detectives studying clues left behind by invisible actors. And tonight, drifting beside a rogue planet between the stars, you find yourself participating in the same investigation. The darkness surrounding you no longer feels empty. It feels populated by mysteries. Invisible matter. Hidden oceans. Undetected worlds. Unanswered questions. The farther you travel, the more complex the cosmos becomes. And somewhere ahead, among black holes, ancient radiation, and strange signals crossing interstellar space, another layer of mystery is waiting. A mystery that may ultimately determine the fate of every galaxy, every star, every wandering planet, and perhaps the universe itself. The rogue planet continues its silent passage through the galaxy. Millions of years seem to flow around it like a slow cosmic river. The stars shift gradually. Entire constellations form and dissolve. Galactic neighborhoods evolve. Yet the wandering world remains committed to its lonely course through the darkness. As you travel beside it, another presence begins to emerge. At first, it is only a feeling, a subtle distortion, a sense that space itself is behaving differently. The stars ahead no longer appear perfectly arranged. Their light seems stretched, bent, slightly displaced. And then you realize why. Gravity is reshaping the view. Somewhere nearby lurks one of the strangest objects in the known universe. A black hole. You cannot see it directly. That is one of the defining characteristics of black holes. They emit no light of their own. No beacon announces their presence. No warning sign hangs in space politely informing travelers that reality is about to become complicated. Instead, they reveal themselves through their influence. A familiar theme in tonight's journey. Again and again, the cosmos introduces important things by their effects rather than their appearance. Dark matter, gravity, rogue planets, and now black holes. One established scientific fact is that black holes form when sufficient mass becomes compressed into an extraordinarily small region. The resulting gravity becomes so intense that not even light can escape once it crosses a boundary known as the event horizon. The event horizon is not a physical surface. It is not a wall. It is not a shell. It is a limit. A point beyond which all possible paths lead inward. You stare toward the darkness ahead. The black hole remains invisible. Yet the surrounding stars appear distorted into arcs and curves. Their light bends while passing through warped spacetime. Einstein predicted such effects more than a century ago through general relativity. The theory remains one of humanity's greatest scientific achievements. Its predictions have repeatedly matched observations with astonishing accuracy. Even now, as you watch distant starlight curve around an invisible object, You are witnessing one of its consequences. The rogue planet drifts onward, far enough away to remain safe, close enough to experience the black hole's influence. And suddenly the lonely wanderer feels less alone. Throughout the galaxy, hidden companions exist. Neutron stars, white dwarfs, black holes, objects left behind when massive stars complete their lives. The cosmos is filled with stellar ghosts. Some shine faintly. Some remain nearly invisible. Some bend reality itself. A surprising observation about black holes is that the Milky Way may contain millions of them. Most remain undiscovered. Only a fraction have been identified through their interactions with nearby matter. This means countless black holes may wander through the galaxy unnoticed. Some could drift through regions populated by rogue planets. Some might pass within a few light-years of wandering worlds. Some may even possess planetary companions captured through gravity long after their original stars disappeared. The possibilities are fascinating and largely unexplored. You look toward the rogue planet beneath you. Compared to the black hole ahead, the world seems small and fragile. Yet both objects are products of the same cosmic story. Gravity shaped them. Gravity guides them. Gravity determines much of their future. The more astronomy advances, the more gravity appears to be the great architect of the universe. Stars form because gravity gathers gas. Galaxies form because gravity gathers stars. Black holes form because gravity overwhelms other forces. And rogue planets exist because gravity occasionally throws worlds into exile. The same force creates order and chaos simultaneously. As you continue observing the black hole, another mystery emerges. Scientists understand many aspects of black hole behavior remarkably well. They know how black holes form. They know how black holes grow. They know how black holes influence surrounding matter. Yet one profound question remains unresolved. What happens to information that falls inside? This is known as the black hole information paradox. The problem sounds deceptively simple. According to quantum physics, information should never truly disappear. According to classical interpretations of black holes, information crossing the event horizon may become permanently inaccessible. Those ideas appear difficult to reconcile. For decades, physicists have debated possible solutions. Some propose information remains encoded on the event horizon. Others suggest subtle quantum processes preserve it. Still others argue that a deeper theory of quantum gravity will eventually resolve the contradiction. At present, no universally accepted answer exists. The paradox remains one of the great unsolved problems in theoretical physics. You drift quietly, contemplating the question. A rogue planet wandering through darkness. A black hole concealing secrets behind an invisible boundary. Both remind you that knowledge often has limits. Not permanent limits, perhaps, but limits nonetheless. Beyond the black hole, the galaxy continues unfolding. Clouds of gas shimmer faintly. Distant stars pulse. Ancient clusters orbit the Milky Way's center. And at the very heart of the galaxy lies an even greater black hole. A supermassive giant known as Sagittarius A star. Containing roughly 4 million times the mass of the Sun, it occupies the center of our galactic home. Astronomers have tracked stars orbiting this invisible object for decades. Those stellar motions provide some of the strongest evidence for its existence. Again, the black hole reveals itself through influence. Never directly. Always indirectly. Like a character whose presence dominates a story despite remaining hidden offstage. One light-hearted observation comes to mind. The universe seems oddly fond of invisible things. Dark matter is invisible. Black holes are invisible. Most rogue planets are nearly invisible. At this point, astronomers might reasonably suspect the cosmos is running an elaborate hiding contest. And unfortunately, the universe appears to be winning. The rogue planet moves onward. The black hole slowly recedes behind you. Its gravitational distortions diminish. The stars return to their ordinary appearance. Yet the encounter leaves an impression. You have passed near one of nature's most extreme creations, a place where space and time behave in ways that challenge intuition. And remarkably, the mystery does not end there. Because black holes are no longer the only cosmic puzzles demanding attention. Across the galaxy, astronomers have detected signals that appear unexpectedly bright, unexpectedly brief, and unexpectedly difficult to explain. Mysterious flashes crossing immense distances. Bursts of energy lasting fractions of a second. Messages without clear senders. The darkness between stars is speaking, and nobody is entirely sure what it is trying to say. The black hole fades into the distance behind you. Its invisible gravity no longer bends the stars around your path, yet the memory of it lingers. The rogue planet continues drifting through the galactic darkness, carrying you deeper into regions where certainty becomes increasingly rare. Ahead, the stars appear calm, silent, unchanging. But appearances in astronomy can be wonderfully deceptive. The universe is constantly communicating, not through words, not through deliberate messages, but through light, radiation, particles, and waves crossing unimaginable distances. Every star broadcasts information. Every galaxy leaves clues. Every black hole influences its surroundings. The challenge is learning how to listen. As you travel beside the wandering planet, your attention turns toward one of the strangest discoveries of modern astronomy. A signal appears. Not visible to your eyes. Not audible to your ears. Yet powerful enough that radio telescopes across Earth would immediately notice it. For a tiny fraction of a second, a burst of energy flashes through space. Then it vanishes, gone almost as soon as it arrived. This is the phenomenon known as a fast radio burst, or FRB. One established scientific fact is that astronomers have detected thousands of these brief radio flashes originating from distant regions of the universe. Some release astonishing amounts of energy in milliseconds. Enough energy that, if converted into visible light, they might briefly outshine entire galaxies. And yet they last only moments. Tiny flashes in the vast darkness. The first fast radio burst was discovered accidentally in 2007 while scientists were reviewing old observational data. At first, researchers wondered whether the signal might be an error. Perhaps interference from Earth. Perhaps an instrument malfunction. But additional bursts appeared. Then more. Eventually, it became clear that something real was happening. Something powerful. Something distant. Something still not completely understood. The rogue planet continues onward beneath you as you imagine those mysterious flashes traveling across the cosmos. For millions of years they move through intergalactic space, passing galaxies, passing stars, passing wandering planets like the one accompanying you tonight. Most continue unnoticed. A few eventually reach Earth. And there, after journeys spanning billions of years, they briefly register inside radio telescopes. A cosmic whisper arriving from unimaginable distances. One surprising observation is that some fast radio bursts repeat. Others do not. Some appear only once. Some return again and again. This difference suggests there may be multiple causes. Magnetars, highly magnetic neutron stars, currently represent one leading explanation for many bursts. Observations have linked at least some FRBs to these extraordinary objects. Yet not every burst fits neatly into existing models. Questions remain. As usual, the deeper astronomers investigate, the larger the mystery becomes. You look upward. The stars remain serene. No obvious sign reveals where the bursts originate. The universe often hides dramatic events behind peaceful appearances. A lesson repeated throughout tonight's journey. Beneath frozen surfaces may lie oceans. Within darkness may hide rogue planets. Around invisible objects spacetime may twist. And behind ordinary starlight may lurk phenomena we barely understand. The rogue planet drifts onward. Then another mystery enters the story. Not a signal. Not a burst. A structure. An anomaly so large that it challenges easy explanation. Astronomers studying the cosmic microwave background, the faint afterglow of the Big Bang, noticed something unusual. A region of the sky appeared slightly colder than expected. This feature became known as the cold spot. The cosmic microwave background itself is an established scientific fact. It represents ancient radiation released roughly 380,000 years after the Big Bang, when the universe cooled enough for light to travel freely. Today that radiation fills all of space. It serves as a snapshot of the infant cosmos. Most of it behaves exactly as cosmological theories predict. But not every detail. The cold spot remains an intriguing puzzle. Some researchers suggest it may result from a giant cosmic void located between us and the background radiation. Others propose statistical chance. Still others have explored more exotic possibilities. At present, no definitive explanation exists. The mystery remains open. And so the rogue planet continues through a universe where even ancient light preserves unanswered questions. You begin noticing a pattern. The greatest mysteries are often not spectacular explosions or dramatic catastrophes. Many are subtle. Tiny deviations. Unexpected measurements. Slight discrepancies. A signal arriving too early. A galaxy rotating too fast. A region appearing colder than expected. Science frequently advances by paying attention to small surprises. The universe rarely shouts its secrets. More often, it whispers them. You continue listening. Far away, another strange signal emerges. Not radio waves this time. Ripples. Tiny distortions moving through spacetime itself. Gravitational waves. Einstein predicted them in 1916. For a century they remained undetected. Then, in 2015, humanity finally observed them directly. Two black holes had collided over 1 billion light-years away. The merger released enormous energy. The resulting ripples traveled across the universe. Eventually they reached Earth. Sensitive instruments measured changes smaller than the width of a proton. An astonishing achievement. And a reminder that spacetime is not merely an empty stage upon which cosmic events occur. It is an active participant. It stretches, warps, vibrates, responds. You imagine gravitational waves passing through the rogue planet, through the Milky Way, through yourself. Invisible ripples crossing cosmic distances. Most are too weak to notice. Yet they carry information from events otherwise hidden from view. Black hole mergers. Neutron-star collisions. ancient cataclysms occurring beyond ordinary observation. Again, astronomy reveals the invisible through indirect clues. The same theme continues. And perhaps that is fitting, because the universe itself appears built from hidden layers. Dark matter, dark energy, quantum fields, invisible forces, unseen structures. Reality often conceals its deepest machinery beneath the surface. The rogue planet glides steadily forward. The darkness feels richer now, not emptier, filled with signals, waves, and mysteries crossing every direction. Some have explanations. Some do not. Some may remain unsolved for generations. And as you accompany this wandering world farther from familiar stars, your thoughts begin reaching beyond the galaxy itself, beyond black holes, beyond fast radio bursts, beyond the Milky Way, toward the earliest moments of cosmic history, because somewhere in the distant past, long before rogue planets existed, long before stars illuminated the darkness, something extraordinary happened. The universe began, and hidden within that beginning may be the deepest mystery of all. The rogue planet continues its journey. Behind you lie black holes, hidden oceans, dark matter, and strange signals crossing the galaxy. Yet now your attention shifts even farther outward, or perhaps farther backward, because in cosmology distance and time are often the same thing. When you look deeper into space, you are also looking deeper into history. The stars shining above the rogue planet are not showing you the present. They are showing you the past. A nearby star may appear as it existed years ago. Distant galaxies reveal themselves as they were millions or billions of years earlier. The farther your gaze travels, the younger the universe becomes. Eventually, if you look far enough, you approach the earliest chapters of cosmic existence itself. The rogue planet drifts through darkness that began long before it was born, long before the Milky Way formed, long before planets existed anywhere. And that realization leads you toward one of the most profound questions in science. How did everything begin? One established scientific fact is that the observable universe has been expanding for roughly 13.8 billion years. Evidence for this expansion comes from multiple independent observations. Galaxies are moving apart. The cosmic microwave background fills space. The abundance of light elements matches theoretical predictions. Together, these observations strongly support what we call the Big Bang model. Contrary to a common misunderstanding, the Big Bang was not an explosion occurring inside space. It was an expansion of space itself. Every region moved away from every other region. The entire observable cosmos evolved from an earlier, denser, hotter state. As you drift beside the rogue planet, you imagine reversing cosmic history. Galaxies move closer together. Stars disappear. The Milky Way shrinks. Matter becomes denser. Temperatures rise. Eventually, planets cease to exist. Atoms cease to exist. Even familiar particles begin to behave differently. The universe transforms into something almost unimaginable. Yet remarkably, scientists can reconstruct portions of that history with impressive confidence. The cosmic microwave background provides a snapshot of the infant universe. Particle physics helps explain conditions shortly afterward. Observations of galaxies reveal how structure gradually emerged. The picture is incomplete, but it is astonishingly detailed. One surprising observation is that the early universe appears remarkably smooth. Matter was distributed with extraordinary uniformity across enormous distances. Tiny fluctuations existed, but overall the cosmos was surprisingly even. This creates an intriguing puzzle. How did distant regions become so similar when they seemingly lacked enough time to exchange information? To address this mystery, cosmologists developed the theory of cosmic inflation. According to inflationary models, the universe experienced an extremely rapid expansion during its earliest moments. An unimaginably tiny region expanded dramatically in a fraction of a second. Inflation explains many observed features of the cosmos. It helps account for large-scale uniformity. It predicts patterns that match observations of the cosmic microwave background. Many cosmologists consider it one of the leading explanations for the universe's earliest evolution. Yet inflation itself raises additional questions. What caused it? How did it begin? Why did it stop? Those mysteries remain unresolved. The deeper you travel into cosmic history, the more frequently answers transform into new questions. The rogue planet continues onward. Its lonely existence now seems connected to much larger processes. Without the Big Bang, no galaxies. Without galaxies, no stars. Without stars, no planets. Without planetary systems, no rogue worlds wandering through darkness. Everything traces back to those ancient beginnings, and perhaps even further. Some speculative theories suggest that our universe may be only one region within a much larger reality. Others propose cycles of expansion and contraction. Still others explore quantum origins emerging from conditions unlike anything humans have directly observed. It is important to distinguish between observation and speculation. The Big Bang model is strongly supported by evidence. The existence of inflation enjoys substantial support, though details remain uncertain. Ideas involving multiple universes remain highly speculative. Interesting possibilities, yes. Established conclusions, not yet. Astronomy advances by maintaining that distinction. Wonder thrives best when paired with honesty. You continue drifting beside the rogue planet. The darkness around you begins to feel different. Not empty. Ancient. Every atom inside the wandering world was forged through cosmic history. The heavier elements originated within stars. Those stars inherited material from earlier generations. Everything connects. Every rock. Every planet. Every galaxy. Even the rogue planet carries a history stretching back to the earliest epochs of existence. Then another mystery emerges. One perhaps even larger than dark matter. Dark energy. In the late 20th century, astronomers made a startling discovery. The expansion of the universe is accelerating. Galaxies are not merely moving apart. They are moving apart faster over time. Something appears to be pushing cosmic expansion forward. That something is called dark energy. One of the most surprising observations in all of science. Gravity should slow expansion. Yet observations reveal acceleration. The universe appears to possess a component that behaves unlike ordinary matter, unlike dark matter, unlike anything directly familiar. Dark energy may account for most of the total energy content of the cosmos, and yet its true nature remains unknown. Think about that. The largest scale behavior of the universe may be controlled by something we do not fully understand. It is a humbling realization, and a beautiful one, because it reminds you that discovery is far from complete. The greatest mysteries are not behind us. They remain ahead. The rogue planet drifts onward beneath the distant glow of ancient stars. It has traveled through billions of years of cosmic evolution. It exists because of processes that began near the dawn of time. And still the story remains unfinished. Dark matter remains unidentified. Dark energy remains mysterious. The earliest moments remain partially hidden. The origins of existence itself remain uncertain. Yet somehow that uncertainty does not diminish the beauty of the cosmos. It enhances it. The universe becomes larger when mysteries remain. Deeper. More interesting. More alive. And as you continue following this wandering world through the darkness between stars, your attention slowly turns inward, toward questions not only about the universe, but about your place within it, about time, about existence, about what it means for conscious beings to emerge inside a cosmos so vast and mysterious. The rogue planet continues drifting through the darkness. Billions of stars remain scattered across the galaxy around you, yet they feel impossibly distant now. The questions occupying your thoughts have become larger than individual stars, larger than planets, perhaps even larger than galaxies. The journey has carried you from frozen landscapes into hidden oceans, from dark matter halos to black holes, from mysterious radio signals to the origins of cosmic history. And yet, somehow, the deepest mystery may not be any of those. It may be the fact that you are here to wonder about them at all. The rogue planet turns slowly beneath you. Its surface remains silent. Its frozen plains stretch endlessly toward unseen horizons. No civilization illuminates the darkness. No city lights shine from beneath the ice. No visible observer accompanies its journey. And yet you cannot help imagining what it would mean to live there, to spend an entire lifetime beneath an eternal night sky, to never experience sunrise, to never know the warmth of a nearby star, to look upward and see only distant points of light scattered across immeasurable darkness. Perhaps such a civilization, if it existed, would develop a very different philosophy. Or perhaps not. One of the surprising observations about intelligent beings is that curiosity appears remarkably persistent. Humans have questioned reality in every era of recorded history. Ancient astronomers studied the stars. Philosophers debated the nature of time. Scientists investigated matter, motion, and existence. The questions changed shape, but the desire to understand remained. Even on a rogue planet, curiosity might eventually emerge. Someone might ask where the distant stars came from. Someone might wonder why gravity exists. Someone might begin searching for patterns hidden within the darkness. The universe seems unusually effective at producing mysteries, and conscious minds seem unusually determined to pursue them. That combination may be one of the most remarkable features of reality. One established scientific fact is that every atom in your body originated within stars. Hydrogen emerged shortly after the Big Bang. Heavier elements formed through stellar fusion and supernova explosions. The calcium in your bones, the oxygen you breathe, the iron in your blood, all were forged long before Earth existed. Carl Sagan famously summarized this idea by saying that we are made of star stuff. The phrase remains powerful because it is literally true. You are connected to cosmic history in a direct physical sense. The rogue planet beneath you is made from the same ingredients. So are galaxies. So are black holes indirectly through the stars that create them. Everything participates in a shared cosmic story. Yet consciousness introduces something unusual into that story. Matter begins asking questions about itself. The universe becomes capable of self-reflection, at least in a limited way. That realization feels almost impossible to fully absorb. For billions of years, stars formed and died. Galaxies collided. Black holes grew. Dark matter shaped cosmic structure. Then eventually, on at least one small planet orbiting an ordinary star, living beings emerged and began wondering about all of it. The fact that such questioning is possible remains extraordinary. Of course, scientists continue debating many aspects of consciousness. Its precise nature remains unresolved. Its origins remain actively studied. Some researchers focus on neural processes. Others explore information theory. Many questions remain open. What seems clear is that consciousness arises within the universe rather than outside it. Whatever it ultimately proves to be, it belongs to the same cosmic history as everything else. You continue drifting. The rogue planet moves through darkness unchanged. Yet your perspective begins to shift. Earlier, the planet seemed lonely. Now it seems connected. Connected to stellar evolution. Connected to galactic formation. Connected to the Big Bang. Connected to mysteries stretching across billions of years. Isolation and connection coexist. A lesson that appears repeatedly throughout cosmology. Galaxies appear isolated, yet belong to larger structures. Stars seem independent, yet share common origins. Planets wander alone, yet remain products of cosmic evolution. The universe is simultaneously fragmented and unified. Another question slowly emerges. What exactly is time? The answer appears obvious at first. Time is what clocks measure. Seconds, minutes, hours, years. Yet modern physics complicates that intuition. Einstein demonstrated that time behaves differently depending on motion and gravity. Time can slow. Time can stretch. Different observers may experience different durations. One established scientific fact is that precise clocks placed in different gravitational environments tick at slightly different rates. The effect is real. Satellites must account for it. Without relativistic corrections, modern navigation systems would fail. Time is not the simple universal background people once imagined. It is woven into spacetime itself. And yet deeper mysteries remain. Why does time appear to flow in one direction? Why do memories point toward the past rather than the future? Why did the early universe begin in such an unusually ordered state? Physicists continue investigating these questions. No final answer exists. The arrow of time remains one of science's most profound puzzles. The rogue planet continues moving forward. But what does forward truly mean on cosmic timescales? Millions of years pass. Stars evolve. Galaxies change. Eventually, even the Milky Way will transform. In roughly 4 billion years, our galaxy and the Andromeda Galaxy are expected to merge. Far beyond that, stars will gradually exhaust their nuclear fuel. The universe's future becomes increasingly strange and increasingly uncertain. Some models predict a cold, dark cosmos populated by stellar remnants and black holes. Others explore possibilities involving dark energy and cosmic acceleration. The details remain unclear. But one thing seems certain. The universe is still evolving. Its story has not reached an ending. Neither has yours. Neither has the rogue planets. As you drift through the darkness beside this wandering world, the original mystery returns. How many such planets exist? How many hidden oceans remain undiscovered? How many secrets travel silently between the stars? No one knows. And perhaps that uncertainty is exactly what makes the journey worthwhile. Because every answer humanity discovers reveals new horizons beyond it. Every mystery solved opens deeper mysteries. Knowledge expands. Wonder expands with it. The rogue planet continues forward. And so does the search. The rogue planet continues its journey. It has been traveling beside you for what feels like ages now, though in truth the distinction hardly matters. Out here, among the immense scales of cosmic time, years and centuries begin to blur together. The frozen world remains unchanged, silent, ancient, patient, and yet, after everything you have seen, it no longer feels like a lonely object drifting aimlessly through darkness. It feels like a question moving through the galaxy, a question the universe has not yet answered. You look outward once more. The Milky Way stretches across the sky in a luminous arc. Hundreds of billions of stars shine within it. Around many of those stars orbit planets. Around some of those planets may exist oceans, atmospheres, and perhaps even life. Between those stars wander countless rogue worlds. Most remain invisible. Most remain undiscovered. Some may have been drifting through interstellar space since before Earth formed. Others may have been ejected only recently on cosmic timescales. Together they form a hidden population scattered throughout the galaxy. One established scientific fact is that astronomers continue finding evidence suggesting rogue planets are remarkably common. Yet even today, nobody knows their true number. The majority remain concealed by distance, darkness, and the limitations of current technology. The mystery that greeted you at the beginning of tonight's journey remains unresolved. And perhaps it should. Because the universe rarely offers complete conclusions. It offers glimpses, fragments, clues. The rogue planet beneath you represents one of those clues. A small piece of a much larger puzzle. You remember the hidden oceans that may lie beneath frozen crusts. The dark matter shaping invisible gravitational structures. The black holes bending spacetime. The fast radio bursts crossing billions of light years. The ancient radiation left behind by the early universe. The dark energy influencing cosmic expansion. Each mystery seemed immense when viewed alone. Together they reveal something even larger. Humanity understands a tremendous amount about the cosmos. Far more than any previous generation. Yet compared to everything still unknown, our knowledge remains wonderfully incomplete. The rogue planet drifts onward. Far ahead, the stars slowly shift. Some are born. Others die. Entire stellar populations evolve while the wandering world continues crossing the darkness. And perhaps somewhere in the distant future, its journey will change. Gravity may eventually guide it toward another star system. A passing encounter could capture it into a new orbit. The exile could become a resident once again. Or perhaps it will continue wandering forever. No law of nature guarantees a reunion. No cosmic map reveals its final destination. The future remains unwritten. That uncertainty extends far beyond a single rogue planet. Astronomers continue asking questions that remain unanswered. What is dark matter? What is dark energy? What occurred before cosmic inflation, if anything? How do gravity and quantum mechanics ultimately fit together? Do hidden oceans elsewhere contain life? Are intelligent civilizations common or rare? What happens inside black holes? Will the universe expand forever? Or does an even stranger future await? These questions remain open, not because science has failed, but because science continues. The existence of unanswered questions is not a weakness of knowledge. It is evidence that discovery remains alive. You look down once more at the frozen world. It turns slowly beneath you. Its surface bears scars from ancient impacts. Its interior may conceal warmth beneath unimaginable cold. Its history stretches across billions of years. And yet much of its story remains unknown. The same is true of the universe itself. Every observation reveals more complexity. Every measurement uncovers additional layers. The deeper we look, the larger reality appears. There is something comforting about that. The cosmos does not become smaller when understood. It becomes larger, more intricate, more beautiful, more mysterious. You continue drifting beside the rogue planet as it moves through the endless darkness between stars. There is no final destination visible ahead. Only possibility. Only unanswered questions. Only the quiet continuation of a journey that began long before humanity existed. The stars shimmer in the distance. Galaxies rotate through cosmic time. Black holes grow. Particles collide. Space expands. The story continues. And now, as the darkness grows softer around you, the journey begins to slow. The questions remain. The wonder remains. The mystery remains. And perhaps that is exactly as it should be. Take one final look across the universe. Notice the stars scattered like distant lanterns across the night. Notice the galaxies gathered into immense structures beyond ordinary imagination. Notice the black holes hidden among them, quietly shaping the paths of light and matter. Notice the tiny quantum particles dancing within every atom, carrying histories that stretch back toward the beginning of time. Notice how cosmic time itself flows across scales almost impossible to comprehend. Stars live for millions and billions of years. Galaxies evolve across epochs. Black holes persist long after ordinary stars have vanished. Meanwhile, entire civilizations appear and disappear within moments of cosmic history. Yet somehow all of these scales belong to the same universe. The smallest particles, the largest structures, the briefest lives, the longest ages, all connected, all participating in a story still unfolding. The rogue planet continues onward through the darkness. The stars continue shining. The galaxies continue turning. The black holes continue guarding their secrets. The quantum world continues whispering beneath reality. And cosmic time continues carrying everything forward. We understand far more than our ancestors ever imagined possible. We have measured distant galaxies, detected gravitational waves, photographed the shadows of black holes, mapped ancient radiation from the infancy of the cosmos. Yet even now, the deepest secrets remain hidden. The darkness between the stars still contains unanswered questions. The universe still contains mysteries waiting to be discovered. And somewhere out there, beyond the reach of sunlight, beyond the familiar pathways of planets and stars, a wandering world continues its silent voyage through eternity. You watch it drift away, smaller, farther, fainter, until it becomes only another mystery among countless others. A quiet reminder that knowledge and wonder travel together, and that the greatest journeys often end not with answers, but with deeper questions. The stars grow softer. The galaxies grow distant. The darkness becomes peaceful. And the universe, vast and ancient beyond measure, continues dreaming its endless dream.